So hello, in this video we are going to start off with a new topic, which is basic maths. Now this is one of the most fundamental topics, the most basic topics that we need to know as we are learning science, right? If even if we are not learning maths, even if we don't have math as a major or a minor, but we need to know basic maths, right? Basic maths. I, as a matter of fact, personally believe that we need to know up to grade 12th, like A1 A2 mathematics, for any field of research. Let it even be biology. Even in biology it is applied. Like obviously in physics and chemistry, mathematics is used quite often, but even for the people who learn biology, I think basic maths till like grade 12th maths or even A2 maths is very fundamental. Why is because in many fields of biology also we are using mathematics. Like let's say for example, Sir Mendel, right? Sir Mendel's what was Sir Mendel's main point that made him stand out, right? It was because he applied statistical data with his biological knowledge to find the Mendel's laws, right? So if we don't know statistics, what is statistics? Statistics is a part of maths, right? So that basic maths is actually, I feel that it is very important for people who are interested in research. Like even into maths fully they should understand and learn at least till even into, right? But for people who are not interested in research and are just just need to get through A1 A2 physics, chemistry and biology. Obviously at that level, in biology mathematics is not used, but till grade 12th biology mathematics is not used that much. But in physics and chemistry, even then in physics and chemistry mathematics is used. And now in this playlist, in this video, we are going to start off with some basic topics of maths. We're going to learn some basic topics of maths that will be used very frequently in physics, especially in physics, and also in some parts of chemistry, right? So starting off with trigonometry. Trigonometry is something that is used very often in physics and chemistry as well. Sometimes in chemistry, more frequently in physics, because we apply a lot of vector mathematics. And even in vector mathematics we are going to use sine and cosines, and a lot of trigonometry we are going to use. So we need to understand basics of trigonometry. Let's start. What is We need to first understand what is trigonometry, right? What is it? Like what do we learn in trigonometry, right? Trigonometry is essentially the study of sides and angles of a triangle. So like let's say any triangle you take, we can take any triangle. Let's say we're taking this triangle. So this triangle has three angles, right? Because the name itself is a triangle, right? Triangle means there are three angles, right? So triangle, this polygon has three angles and it has three sides, right? Let's say the vertices are A, B and C. The length is, let's say this is A and this is B and this is C, and this angle is A, this angle is B, this angle is C, right? So this is a basic, in general, it's a general form of a triangle, general form of a triangle. Now one might ask, and what we are going to learn in trigonometry is essentially the relation. It's the relation between angles and sides of a triangle. So if we are relating the angles and sides of this triangle, that study, it actually comes under trigonometry, right? Now, one might ask, actually, if you think about it, one might ask, why only triangles, right? Why are we learning about triangles in specific? Why are we learning only about triangles and not about polygons in general? Because like life is made up of many polygons. Like even in mathematics, we are going to use polygons, not specifically triangles, right? Why not? We are learning about squares. Why not we are learning about rectangles or a pentagon? Why not? Why only a triangle? Now, the reason behind that is actually quite simple. It's because the most fundamental and basic type of polygon is the triangle, right? Triangle is the most basic. It's a polygon which has least sides. It's the first polygon, you can say, the most basic type of polygon. And any polygon, listen carefully, any polygon can actually be divided into triangles, right? Any polygon can be divided into triangles. So let's say we have, let's say, a square or a rectangle. Let's say we have a rectangle. Now this rectangle, if we need to find the sides and angles of this rectangle, what we can do is we can actually divide it into two triangles. Now this is one triangle, this is second triangle, right? And if we know how to find the sides and angles, or how to relate the sides and angles of a triangle, then we can find the sides and angles of this rectangle as well, right? Because we have divided it into triangles. Now let's say we have a pentagon having 5 sides, right? 1 2 3 4 5, right? 5 sides. We can divide this into 3 triangles, right? 1 2 3. So like this we can divide any polygon into multiple triangles. And if we know how to find the sides, and or if we know how to relate the sides and angles of a triangle, then we would know how to find the sides and angles of any polygon, right? Of any polygon. So instead of learning individual methods of how to find the sides and angles of a rectangle, then a pentagon, then a hexagon, then a octagon or something, nonagon or decagon or something, anything of a polygon, of like infinite polygons, instead of learning that, why not learn the relation between sides and angles of a triangle, which is the most basic polygon, and then apply it, and then convert any polygon that you need to find the sides and angles of of that polygon of, and convert that polygon into multiple triangles, then find the sides and angles of the triangle, and then find the sides and angles of that polygon that you need to find of, right? So that is why we are learning about triangles in specific, because we can divide any shape, any polygon. To be accurate, we can divide any polygon into multiple triangles, and then we can find the sides and angles of the triangle to find the sides and angles of the polygon, right? That is why we are learning specifically about trigonometry, meaning which is the study of relation of sides and angles of a triangle. We can write it down. That's the the basic point. Study of relations between sides and angles of a triangle, right? Study of relations between sides and angles of a triangle. Okay, so this is a basic triangle. Now triangles also can be of many types, right? Triangles also can be of many types. It can be an obtuse angle triangle, or an acute angle triangle, or a scalene triangle, or an isosceles triangle, or a right angle triangle. Now there are many different types of triangles, right? So but even if we want to further simplify the triangles also, into a specific type of triangle, so that then we can find the specific type of triangle, and then apply it to the triangle, then apply it to the polygon which we have divided into multiple triangles. So that would make it even more simpler, right? Even more basic, right? Instead of learning different relations for different types of triangles, instead of doing that, instead of learning different relations for scalene triangle, different relation for isosceles triangle, for different relation for obtuse angle triangle, instead of doing that, why not just learn a specific relation for a specific type of triangle? Why not learn specific relations for a specific type of triangle that we can apply for all triangles, right? That would be better, right? We can divide any triangle. Now this also comes again, right? This is very a very beautiful concept. You have to understand. See, right? Polygons. For any polygon, we can divide any polygon into triangles, into multiple triangles, right? We can divide any polygon into multiple triangles, and we can divide any type of triangle. Let it be a obtuse angle triangle, a scalene triangle, an isosceles triangle, any triangle, any type of triangle. We can divide any type of triangle into a right angled triangle, right? We can. So are you seeing how we are simplifying it, right? We are going from polygons, we are dividing the polygons into triangles, then we are dividing the triangles into right angled triangles. Actually we can divide any triangle, write it down. We can divide any triangle into two right angled triangles, into exactly two right angled triangles. We can divide any triangle, any type of triangle, you can try it out, into two right angle triangles. And now if we learn about the relations of sides and angles between any right angle triangle, if we just take right angle triangle, learn the or study the relations of sides and angles between in a right angle triangle, then we can apply it to any triangle. Further we can apply it to any polygon, right? So that is the basic point. So in trigonometry, actually we are learning the study of relation between sides and angles of a triangle, but more specifically even right angle triangles, right? Even right angle majorly right angle triangles, right? Because when we are learning about sine, cosines, all these things are actually more specific for right angle triangles. Now what are right angle triangles? Obviously you know what right angle triangles are. Right angle triangles are those triangles which have a 90-degree angle as the largest angle. Obviously the sum of all angles of a triangle is essentially 180. Sum of all angles of a triangle is 180, and if one angle is 90 degrees, the other two will obviously be together 90 degrees. So if one angle is theta, the other angle becomes 90 minus theta, right? Obviously I hope you understood. See, if one angle is 90 and the sum of all angles of a triangle is 180, then the sum of the other two angles will be 90, because 90 plus 90 would be 180. So if this is 90, these two must add up to 90. So 90 minus theta plus theta is 90, right? So that is why if this is theta, this is 90 minus theta. Okay, and we are just naming a general, like we named a general triangle, like that we are naming a general right angle triangle. We are just naming a right angle triangle, general right angle triangle. And let's say this is a b c, right? Let's say this is abc. So the side opposite to the largest what do you say, the largest angle, the side opposite to the largest angle, which in this case is 90 degrees, which in all right angle triangles is 90 degrees. So the side opposite to the 90-degree angle is the AC side, which is the largest side of the triangle, and is also called, it is named hypotenuse, right? Obviously you know this basic stuff. The angle, if we take this as theta, just theta is just a general angle. Theta is just a general angle. I will talk about what angles are also, right? Because I feel maybe if I don't explain what angles are, how can I use the term angles, right? But just give me a minute, I'll explain what angles are. Let's say this is an, okay, first I'll explain what angles are. Okay, angles. Okay, let's say what angles are. Let's understand what angles are. Now, to be very honest, even if you think about it, even if you think very deeply about it, we know that there are angles. We know that there are angles, but we don't know what angles are, right? We don't know what it means, right? What it means. What are angles, right? We don't truly feel it. So essentially the definition of an angle is essentially, it is the space. It is the space between two lines, that are intersecting at a point. Space between two lines intersecting at a point is an angle, is the angle between the two lines, right? So if we are talking about these two lines, this space between the two lines that are intersecting at a point, the space between, yeah, this space is the angle between the two lines. That is the basic point, that is the basic meaning of the angles, right? Meaning of an angle. Now there are different ways to measure an angle. We will come back to where we left off in this hypotenuse part, but there are different, first we need to understand what angles are, right? Because here I got ahead of myself. I first need to make you understand what angles are, because you know what sides are, right? We know study of relation between sides and angles of a triangle. You know what sides are, but first you need to understand angles, and only then can we go to learning trigonometry. Now how do we measure angles? First we understood what angles are. Now how do we measure angles, right? There are many different ways of measuring angles. Let's say the most common is the degree method, and then there is the radian way, right? Like let's say you have a mass, right? Let's say you have a mass of m mass, right? Now this m mass, it can be in kilos, right? If it is m kilos, it is m kg, right? But if it is in m grams, it is m thousand, it is m into thousand grams, right? Because 1 kilo is 1000 grams. So you can write it in different, the units are different, right? The basic point is units are different. The kg and gram unit are different. So similarly, what is the unit of an angle? We know the physical quantity is the space between the two lines, like we know mass is mass, But what is the unit that we use or give to the angle? What is the unit? The most common unit, there are two units that are mostly used. Two units are there, but there are also solid radian also are there, but that is for 3D shapes. But mostly we only use degree, which you might have already heard. Sorry, there's only two e's: degree and, let's say, the degrees, and then there is radian. Degrees and radian, right? Degree and radian measure are there. Two things are there: degree and radian measure. Now let's understand where did all these things come from, like degree and radian. Simple thing. Let's say you have a circle. Let's say you have a circle with a point at the center. You are dividing the circle into 360. You are dividing the circle through the center of the circle using diameters, right? Using diameters, you're dividing the circle through the center of the circle into 360 parts. So let's say you have a pizza, you cut the pizza like this, right? So across the circle through the center of the circle, you're cutting the circle into 360 parts. Let's say you are cutting the circle in 360 equal parts, right? Equal parts. That is the main point. You're cutting the circle in 360 equal parts. You're taking a circle, cutting the circle into 360 equal parts through the diameter, using diameters through the center. Then the angle made at the center by each section of the 360 parts, the angle made at the center by each section of the 360 parts is 1 degree. Simple, understood? You take a circle, divide the circle into 360 parts through the center using diameters, and the angle subtended by adjacent diameters, or the angle subtended by one section, the angle subtended by one of the 360 sections, any one of the 360 sections, the angle subtended at the center is 1 degree. Okay, so that means in a circle there will be total how many degrees? There will be total 360 degrees, because there are 360 sections. And if one section is 1 degree, if the angle subtended by one section is 1 degree, then angle subtended by 360 sections will be 360 degrees. And that is how 1 degree is defined. Like, that is how it is defined. Okay, like 1 kilo is defined as one, they have an element which is an alloy. I think it is a platinum or something. It is an alloy, and they have used that as the 1 kilo, right? In SI, like we have all mutually agreed that this mass is 1 kilo, right? Similarly, we are all mutually agreeing that if you take any circle, divide it into 360 parts, and 360 equal parts using diameters subtended by diameters going through the center, then the angle subtended by one section is 1 degree. And like that we have assumed. Okay, we have not assumed, we are more like it's agreed upon by everyone. That is how it is. Okay, so that is how you find out degrees. Now how do we find out radian? Now radian measure is also a different concept. It's a very good how the way we measure 1 radian, the way we define 1 radian is very beautiful. Let's say you have a circle, and you're taking a circle of r radius. Okay, you're taking a circle of r radius is r, and you are taking another a radius of r length, obviously, right? And this length that is cut by the two r radiuses on the circumference of the circle is also of r length, and this length is actually called the arc length, right? The arc length. What is an arc? Is that curve. Arc is that curve, and the length of that curve is called the arc length. So the arc length. So basic point is, when such a case is there, when we come across such a case where the angles, where if there is a circle of r radius and an arc length of r is found, then the angle subtended at the center of the circle, this angle subtended at the center of the circle is said to be 1 radian. Okay, is said to be 1 radian. Angle subtended by is said to be 1 radian. Maybe I wasn't able to explain it very well, but I'll explain it once more. Because of lack of space. Anyways, okay, I'll just take it up again, that radian part. Maybe you didn't understand it. Maybe I wasn't able to explain it very well. I feel that you didn't understand because I didn't explain it very well. That's why once more I'll explain. See, you have a circle. Okay, you have a circle. That circle is of r radius. Then you take an arc length. Of r length. The angle subtended at the center of the circle. At this case, when the arc length is r and for a radius of r, for a circle of radius r, then this angle subtended at the center is said to be 1 radian. Okay, like in the case of degrees, it was more like they just divided the circle into 360 equal parts by through the center. Then the angle subtended at the center by each of the section is 1 degree. Like that. In this case, it is that if you're taking a circle of r radius, take an arc length of r, the angle subtended at the center by this arc length of r is essentially 1 radian. Okay, and like that, in a circle, in any circle, you take any circle, you will find that there are a total of 6.28, not an exact number, but there is a total of 6.28 radians in any circle. You take any circle, you will find that there are 6.28 r lengthed arc lengths, right? 6.28 r lengthed arc lengths. Yeah, I hope you're feeling what I'm trying to say. Like if you take like this, there will be 6.1 2 3 4 5 6.28, right? There are one, so this is 1 radian, this is 1 radian, this is r length ka 1 radian, r length 1 radian, r length 1 radian, r length 1 radian, r length 1 radian. There are 6 r length 1 radian. This is 0.28 r lengthed radian, right? So 0.28, right? So there are total 6.28 radians in any circle. Take any circle, there are total 6.28 radians, right? This 6.28 might be a familiar number because it is actually the double of pi. Pi is 3.14. 2 into 3.14, right? 2 into 3.14. So 2 pi radian. So we can say in a way that there are 2 pi radians in the 2 pi radian is the angle subtended by a circle at its center. Angle subtended by a circle at its center is 2 pi radian. Okay, the maximum angle is 2 pi radian. Okay. So now in degree measure, what was it? In degree measure, it was 360 degrees was there in a circle. The angle subtended by the center of a circle is 360 degrees, and in radian measure, it is 2 pi radian. So both of them, because both of them are the angle subtended by the circle at the center of a circle, of any circle, that means 360 degrees is actually equal to 2 pi radian. Okay, it's actually equal to 2 pi radian. And that also means that pi radian is equal to 180 degrees. That also means that if we need to interconvert, right? If we, like, we know that 1 kg is 1000 grams, but how do we know how many radian are degrees? This is how we know, right? This is how we find out, because angle subtended by full circle is 360 degrees, angle subtended by full circle is 2 pi radian. So 2 pi radian is 360 degrees. That means pi radian is 180 degrees. That also means that 1 radian is equal to 180 by pi, right? 1 radian is 180 by pi, and 1 degree is equal to pi by 180 radians. 1 radian is 180 by pi, and 1 degree is pi by 180 radian, right? 1 radian is 180 by pi degrees, and 1 degree is pi by 180 radian. So if we have any degree, let's say 36 degrees, then just multiply 36 on both sides, you will find that 36 degree is equal to 36 pi by 180 radian, right? That is how you interconvert. Like we need to interconvert, we need this to interconvert between kg and grams, like that. This is what we need to interconvert between degree and radian. Now coming back to where we left off, to understand what now we understood what angles are, right? Angles, now we understand the study of a relation between sides and angles of a triangle. We know what sides are, we know what angles are. Sides obviously means the length, right? And now we are going to learn about the the triangle, so polygon to triangle to right angle triangle. And so if this is theta angle, if this is theta angle, then the side opposite to the theta angle, the side opposite to the theta angle, we can say it is the opposite side. Just say opposite side, the side adjacent to the theta angle. Now there are two sides adjacent to the theta angle, which is the hypotenuse also and the BC side also, but the angle, or but the side of adjacent, because we already know, we have already named AC side, which is the hypotenuse, so we can't name it again, right? My name is already fixed. My name is Srijesh now, but how can I name myself twice, right? I can't. So one AC is hypotenuse, AC is already hypotenuse, so the adjacent side implies the unnamed side. So theta has one unnamed side, which is this is adjacent, right? So with respect to this theta, with respect to this angle, let's say with respect to this theta or this angle, this BC side is the adjacent side and the AB side is the opposite side. But with respect to the 90 minus theta angle, with respect to 90 minus theta angle, BC side will be opposite because this is opposite, and AB side will be the adjacent one, right? I'm just naming a basic, like we named the sides and angles of a triangle, like that we are naming a general side, the general sides and angles of a right angled triangle, so that we can further find the ratio between them, right? So this is the basic. We today that's this is enough, I think. We learned quite a bit. We learned the basics of trigonometry. We learned what trigonometry is, what are angles. We also learned the degree and radian measure of an angle. We learned degree and radian measure of an angle, and we also learned a bit about why we are learning trigonometry, why only about triangles, why not about any other polygon. And then we also named a general triangle and a general right angle triangle. In the next video we are going to learn the main the main part of trigonometry, like the main part of trigonometry, like sine, cosines, and what do they mean. Then we are going to find the relation between we may even go into the identities, right? The identities of trigonometry. Okay, I hope you understood everything that was explained today. I hope you truly understood everything, because I tried my best. Okay, I'll keep improving if you didn't understand. Okay, now if you didn't understand, just rewatch the video. I'm very sure you'll understand, because I tried to explain to the most basic level that is possible. Okay, but even if even then I couldn't explain it to you, then I'm really sorry. I'll try harder, pakka. Okay, thank you.